Okay, so in this video we're going to go over how to solve speed problems. First we'll start with the basics and go over the speed equation, and then we'll go into some practice problems. Okay, so my speed equation, you've probably seen it before, but speed is equal to how far I travel, my distance over my time. Okay? So speed is how far did you travel over a certain amount of time. You'll often also see it like this. We'll represent speed with the S, the distance with the D, and time with T. So speed equals distance divided by time. So that means that is a division sign there. Okay, so let's go over what is in physics. What do we use in terms of units? So units are what goes at the end of a number. So, for example, am I talking about 1 inch or 1 foot or 1 centimeter? So that ending part, like the centimeter, that's my unit. Okay, so for distance, the unit that we use, our SI unit, our what we call it SI units, are our standard international units. So what we use for distance is meters. Okay, meters, which will often abbreviate with a lowercase m. But you will also see kilometers. That's another common one. You might also see miles. There's various ways to measure distance. Okay, time, same thing. You can measure it in hours, in seconds, in minutes. When we're dealing with physics, our SI unit for time is seconds. Okay, which we measure in. We measure it in seconds. We use a lowercase s to represent that. Okay, and speed. So what do we measure speed in? Well, if speed's distance divided by time, it's meters divided by speed. So it's just m over s, meters divided by seconds. Okay, so I'm gonna show you. You're gonna have problems where you have to solve for all of these here. So I'm gonna show you a quick trick to kind of help you solve multiple problems. Okay, which is what we call our speed triangle. So we just draw something like this. This is what we call our speed triangle. Okay, and we go ahead and put an X here. Okay. So I'm going to go ahead and put speed equals times time. Okay. So using this, we're able to solve for any variable. So for example, how do we do that? Well, all we really have to do is we just block what we are looking for. So let's say I'm looking for speed, right? I block speed. This tells me that speed equals, I read it from top to bottom, distance divided by time. So speed equals distance divided by time. Is that correct? Yes, right? We already solved that. All right, what about distance? Well, distance equals, if I block distance equals speed times time. Distance equals speed times my time that I took. Okay, how do I solve for time? Time equals distance divided by speed. Distance divided by speed. So these are the three equations you will be using. Okay, and you want to be able to use this to solve for all of these. Okay, I mean, you can also just plug and solve, and I'll show you guys that method as well. So let's go ahead and go to some practice problems. Okay, all right. So the first one, it says, I'm actually going to switch this to seconds just to make it like it's an SI unit. Okay, so if a car is traveling at 18,100 meters in 30 seconds, what is the average speed? Well, this is easy, right? If I know I'm using my equation, speed equals distance divided by time, because I'm looking for speed. So usually we like to list everything. Once you get better, you can skip this step. But speed that's our question mark. So we put a question mark. My distance is 1,800 meters. My time is 30 seconds. Okay. All right. So we plug that into my equation. Speed equals distance, which is 1800 meters divided by 30 seconds. Okay, you can use a calculator for that. Go ahead and put that into my calculator. That's going to give me, let's see here, that's going to give me, put that in, divided by this, will give me 600. Okay, so 600. If you put this, you won't get full credit. You need to put the units. So what are my units? Well, meters divided by seconds. My units are meters per second. Okay? Alrighty. Let's go on to the next one. Let's get a little bit more difficult. A rocket travels 5,000 meters at a velocity. Remember, velocity, we can use that interchangeably with speed. So at a velocity of 50 meters per second. So how long did it travel? How long, that means we're referring to time, right? Because it didn't say how far. So speed equals distance equals time equals, I'll still list everything. I know the speed, it's 50 meters per second, right? I know that. The units line up as well. Distance, I know it traveled 5,000 meters. I don't know the time, so I put a question mark. All right, so let's figure out. Now we're looking for how long. So we're looking for time. So if I look at my speed triangle, time equals distance divided by speed. Time equals distance divided by speed. Time equals distance divided by speed. I plug in my information. 5,000 meters divided by 50 meters per second. Okay. If you notice, you have meters on top and you have meters on bottom. Whenever you have something on top and the bottom of a fraction, they cancel out. So this cancels out, this cancels out, right? I'm left with seconds. So this divided by this. So you go ahead, you do the math for that. So 5,000 divided by 50 will give you 100. What are my units? Well, it's time, so it should be seconds, right? And it makes sense because if these units cross out and I'm only left with seconds, my units are seconds. Okay, it's pretty easy. All right, next problem. A rock falls for 10 seconds at a speed of 10 meters per second. How far did it travel? I'm going to skip the listing part because I think, because once you get a little used to it, you can skip that part. Okay, so distance equals, block it, speed times time. So distance equals speed times time. Well, what's my speed? Well, speed of 40 meters per second, right? So I'm going to leave out the units for now. 40 times time is 10 seconds. Well, that's going to give me a distance of traveled of 400 meters. How do I know it's meters? Because it's distance, right? So it's going to be meters. So you could leave out the units and then just put it at the end. That's another option. Okay? That would be my final answer. All right. Keep in mind that my units matter. So you're not always going to be given meters and seconds. It depends on the problem. Okay. So, for example, on this top problem, if I was given, rather than meters, if I was given kilometers, then my answer would have been kilometers per second. So it all depends on the units that you're given. Okay. So even though we commonly use meters per second, that's not always going to be the case. And I'll show you guys that in this example. Okay, so this problem is a little bit more complicated. It says, a person walks 60 meters in 1 minute, then walks 30 meters in 2 minutes. What is their average speed over the 3-minute walk? So I'm looking for speed, right? Because it said, what is their average speed? I don't know. I need to figure out their distance and the time. Well, a person walks 60 meters in 1 minute. So I know they walk 60 meters, right? And then they walk 30 meters. So I know they walk 30 meters. Plus, and then it says, what is their average? Well, what was the time? They did all of this in 3 minutes. So in this case, you had to add everything up, right? Because we want average, we just add everything up. So in total, they traveled 90 meters in 3 minutes. Okay, so speed equals distance divided by time. My distance was 90 meters, so my distance was 90 meters divided by my time, which was 3 minutes, right? So you go ahead and do that. 90 divided by 3 gives me 30. 30 meters per second? No, because there was minutes. So that's what I referred to when I said you might have different units. It all depends on what's given to you. 30 minutes per mile, and that would be my final answer. Okay. If you have any questions, feel free to message me.